All right, as you guys are coming in, those are the answers to 1 through 4 as I'm taking attendance. If you want to check those. So, there we go. There we go. All right. Any questions about 1 through 4? Any questions about 1 through? I am recording, just making sure. All right, everybody good with 1 through 4? Going once. Going twice. All right. So then there is 5 and 6 as well, finding angles.
Can you do number 6?
Absolutely. Okay, so let me sketch it out. Two, 78, 10. Okay. This is A, C, and B. All right. So we are trying to find the measure of angle A. Okay. So basically what we first have to do is find little c because it's a signed angle side situation. All right. So c squared, meaning little c, equals the other two sides squared, so 10 squared plus 22 squared, minus 2 times those same sides, cosine of the angle they give us, which is 78. All right? So 10 squared is 100, 22 squared is 484. So that comes out to be 584. 2 times 10 is 20. 20 times 2 is 440. 440 cosine 78 is 91.5. When I'm done subtracting those, I get 492.5. All right, remember that that's squared, so I got to do the square root. That gives me 22.2. All right. And now, in order to get angle A, I can use law of sines. So 22.2, which I just found in the previous part, over sine of the opposite angle, 78, equals 22 over the sine of A. You should realize those are very close to each other, so my answer should be pretty close as well. So 22 sine 78 divided by 22.2. I get sine A equal to about 0.9693. I do second sine, 0.9693, and I get 75.8. They have 75.9. So depending upon where you round it to along the way is most likely where they're at. So if you were like 1/10 of a degree off, you wouldn't lose. All right, everybody's good through 6. There's 7 and 8.
Could you do number 8 as well?
Absolutely, I can. Okay, so I'm trying to get A. The problem is A is not opposite the biggest side C is. So you got to get angle C first. So cosine C equals, all right, cosine C equals the two sides connected to it. So 15 squared plus 18 squared minus the opposite side squared, all over 2 times those same adjacent sides of the angle. So I got 15 squared plus 18 squared minus 20 squared, all over 2 times 15 times 18. 15 squared plus 18 squared minus 20 squared gives us 149. 2 times 15 is 30. 30 times 18 is 540. So now I'm going to do second cosine and put in 149 divided by 540. That comes out to be approximately, when I put that in, 74 degrees. So that means C is 74 degrees. Now remember, I need to get A. So sine A over its opposite side, 18, equals the sine of C, which is now 74 degrees, over 20. Cross multiply, 18 times the sine 74, divide that by 20. I get sine A equals 0.8651. Second sine, 0.8651. And A equals 59.9 degrees, pounded to the nearest tenth. So there you go. And then for the remaining, solving the triangle, there's 9 through 12.
Can you go over number 12?
Absolutely. All right. Draw it out. 19.9, 9.4, and then 109.5. All right. And A, B, C. All right. Okay, so it's a side angle side situation. So the first thing I'm going to do is get my missing side here. All right. So B squared equals. All right. B squared equals. All right. B squared equals the other two sides squared, so 19.9 squared plus 9.4 squared. Minus 2 times those same two sides, 19.9 and 9.4, and then cosine of the angle between them, 109. All right. 19.9 squared plus 9.4 squared. 484.37. Minus negative 124.88. Means I'm going to add it. At the end of that, I get 609.25 B squared. I then do the square root of that. I get about 24.7. So the missing side is 24.7. All right, now I have to find the remaining angles. To do that, I'm going to use the law of sines. I'm going to put the 24.7 I just got over the sine of 109.5 equals the 9.4 over the sine of A. And then on the other side, 19.9 over the sine of C. I'm going to cross multiply to get C, 19.9 times the sine of 109.5. Divide that by 24.7. Sine C comes out to be 0.7595. Second sine, 0.7595. Makes that about 49.4 degrees. And And then the easiest way to get the third angle, if you don't want to use that, is simply add them up and subtract from 180. 109.5 plus 49.4, 158.9. Subtract that from 180 and you get 21.1. And they have it a little off. A little different, but it's fine. If you're a tenth off, you're fine. All right. Any others from that group? All right, then a really quick note about how you can use area to help find an angle if you get stuck. So basically, all right, you just got to pay attention. You don't have to jot this down, but here's the idea. You get a triangle with sides 12, 16, and 14. All right, we now have two different ways to get the area. Area equals the square root of S minus A, S minus B, S minus C. All right, where S is the perimeter divided by 2. 12 plus 16 is 28, 28 plus 14 is 42, 42 divided by 2 is 21. So this becomes 21 times 21 minus each of those numbers. 9, 5, 7. All right, so this is what you're doing tonight for homework. When I do that math, 21 times 9 times 5 times 7. Raised to the 0.5, and you get an area of approximately 81.3. All well and good, that's what you're doing tonight for homework. Now, the other way of getting area is 1/2 AB sine of the angle between them. So let's say I want to get that angle there. The sides are 12 and 14. I want to do 1/2, 12, 14, sine of the angle between them. Well, depending upon how I got the area there and the area there, they should basically come out to be the same. So you can take that and set it equal to the area you got using Heron's formula, 81.33. All right, you're now going to simplify this. 84 sine C equals 81.33. You can divide both sides by 84. Sine C equals 0.9682. And now you can do second sine, 0.9682. And you get 75.5. So if you get stuck doing the homework, or when you do the quarterly or whatever it is, or when you're taking the quiz on Friday, there's an alternative way to find an angle measure when they give you all three sides. Okay? So that is up to you if you choose to use it. Now, beginning next week, when we go back to hybrid, live streams are still mandatory. So obviously, if you're in school, it doesn't affect that at all. But if you're home, because it's either your hybrid day or your virtual, you're still responsible for logging in to the live stream when class begins. Our class begins at about 11:53. So you are responsible for logging in. I'm most likely not keeping you the entire time. All right, for example, next week will be a very short time because we're just doing word problems with law of sines and cosines. And you'll be working independently. Okay? There's going to be some days where we're here for a good almost 43 minutes. All right, but you are responsible for it. If you're marked present in attendance, all right, you should be in the class. If not, it's considered a cut, whether you're virtual or hybrid or whatever. You are responsible for showing up every day. All right, except on quiz days where most likely you'll just go to Edulastic. But every other day, pretty much expect to join the class or some portion of the class. All right. So let us talk about word problems. The lengths of the diagonals of a parallelogram are 8 feet and 12 feet. Find the lengths of the diagonals if one of its angles measures 59 degrees. Okay, so we're dealing with a parallelogram. Sides are 8 and 12. One of its angles measures 59 degrees. You need to get both lengths of its diagonals, so we'll start with that one. All right? B squared equals the other two sides squared. B squared equals the other two sides squared. Minus double those sides. Cosine of the opposite angle, which is 59. I do that math. 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 59. D squared equals 109.1. I then finish up by doing the square root. D is approximately 10.4. All right. What you have to remember, ladies and gentlemen, is there's also another diagonal and they are not congruent. All right. So basically you have to get then that diagonal as well. This is still going to be 8. This is going to be 12. The difference is instead of working with the acute angle, you're going to be working with the obtuse angle. Well, for those of you that don't recall, consecutive angles of a parallelogram are supplementary, which means they add up to 180. That means that one's 121. Other than that, the problem's exactly the same. 8 squared plus 12 squared minus 2, 8, 12. Cosine, but instead of 59, it's 121. So basically, you do it twice. Once with the angle they give you, once with its supplement. I go to my calculator and I do 8 squared plus 12 squared minus 2 times 8 times 12, cosine of 121. D squared in this case is 306.9. And the square root of that, 17.5. All right. Keep in mind, please, that also works with one of our favorite figures, the rhombus, where all sides are congruent. However, the diagonals are not congruent to each other, so you will have to do it twice. All right. So you may have to do it twice, even though it's an equilateral figure. But the same rules apply. You use that angle, and then it's supplement. Okay? Next up, Artemis seeks knowledge of the width of Orion's belt, which is a pattern of stars in the Orion constellation. She has previously discovered the distances from her house to Alnitak is 736 light years and to Mintaka 915 light years, which are endpoints of Orion's belt. She also knows the angle between these stars in the sky is 3 degrees. What is the width of Orion's belt? That is, what is the distance between Alnitak and Mintaka around nearest light year. So I have myself a triangle. All right, and it says this is her house, this is Alnitak, and this is Mintaka. Again, the triangle just needs to be a structure so we can sort our information. The distance from her house to Alnitak is given as 736. The distance from her house to Mintaka is given as 915. And then they say that angle is 3. We're trying to find the width of Orion's belt, which is out there. All right, so we got side angle side. So the missing side would be the two given sides added up minus double the product of those two sides times the cosine of the angle between them. So it's 736 squared plus 915 squared minus 2 times 736, 915 cosine of 3 degrees. Again, how much you put in the calculator at one time depends upon how good you are at it. But those two squared adds up to 1,378,921. When I do the second multiplication, 2 times 736 times 915 cosine of 3 degrees. That is 134,5034.148. When I do that subtraction, x squared is approximately 33,886.9. And then my last move is the square root of that, which means the distance between them is about 184.1 light years. All right, one more. A bicycle race follows a triangular course with 3 legs measuring in order 2.3, 3.9, and we're going to change that 1 to 6 kilometers. Otherwise, it can't be a triangle. Find the angle to the nearest degree a rider must turn when going between each leg. All right, so basically, they're not asking for a particular angle. They're asking for all of them. 2.3, 3.9, and 6. All right, 6 is the longest side, so the first one I'm going to get is A. All right. Cosine of A, since it's opposite the biggest side, is the two sides of A squared minus the opposite side squared all over 2 times the sides of the angle. These numbers should always match up with those numbers. 2.3 squared plus 3.9 squared minus 6 squared gives us negative 15.5 over 2 times 2.3 times 3.9, 17.94. I'm now going to do second cosine and then put that into the calculator. So second cosine, negative 15.5 divided by 17.94. And it gives me 149.8 degrees. Means my biggest angle is 149.8 degrees. Now to get either one of the remaining angles, I use law of sines. Let's say I want to get B, which is opposite to 3.9. Sine B over 3.9 equals the sine of the angle I just found, 149.8 over 6, since that was the side opposite. I'm going to cross multiply 3.9 times the sine of 149.8. I'm going to divide that by 6. Sine B comes out to be 0.3270. Second sine, 0.3270. And I get B to be approximately 19.1 degrees. And then to get my third and final angle, I'm just going to add these two up. And that gives me 168.9. Subtract that from 180, and I get 11.1. All right. Okay, so tonight, make sure you do that area worksheet as it is due by midnight. Tomorrow, we'll do the remaining 2 word problems, and then any other review problems that's setting you up for tomorrow's quiz. I'll stay online for about 4 minutes. If you have any questions, feel free to ask them. If not, feel free to be good, be safe, and I'll see you guys tomorrow.
Have a nice day.
Have a good one, guys.
Have a good day.
Thank you, you too.